Hey guys, welcome back to the next part in this live stream series. We're continuing with the development of the humanoid robot. So I have saved you some time and I went ahead and did a lot of boring stuff early on before starting this live stream. So today the main task at hand is connecting these actuators with the motor controllers, and the thing about doing this stuff is, as you can see over here on the motor controller, the soldering points, they are extremely small. As you can see over here, we need to solder these encoder wires on these different spots. They are pretty tiny and they're pretty close together, so there's a real risk of getting them short with each other. And the trouble on top of that is we were supposed to use a 24 gauge wire in this encoder, but if you've seen the last live stream, or if you have been following along with the development of this robot, you probably know that we don't have access to 24 gauge wire. We had this 20 gauge wire lying around in our lab and we soldered that to the encoders. So a 20 gauge wire is considerably thicker compared to a 24 gauge wire, and that's why we are gonna have more trouble soldering it over here. So it's a way more precise job than what it was already. So what I did to kind of save us some time on this soldering part, I went ahead and made sure these ends of the wires are small. So I went ahead and cut the extra strands of the copper from these wires and tried to make them tiny, so it's a bit easier to get them here on these points and solder them. Now I haven't tried soldering them yet. I'm gonna start doing them now in the live stream, so let's see how it goes. Hopefully it turns out okay. Once we're done doing this, I'm gonna start with the bigger one, and then, because this is gonna be going in the shoulder of the robot, and we are gonna be making the arm of the robot after once we're done working on these actuators. We're gonna be removing supports from some 3D printed parts meanwhile. So as you can see over here, we have the body parts for the robot, the arms, shoulders, stuff like that, and we have yet to remove the supports from those parts. So we're gonna be doing that in parallel. I'm gonna be soldering these motor controllers on the actuators we have prepared so far, and meanwhile Ali is gonna be removing these supports from these components, and then we're gonna put together the arm hopefully by the end of this live stream. So yeah, we've been doing soldering assembly for quite a while now, and I'm really excited to see how the arm turns out. So yeah, let's start the process. Alright, just like the previous live streams, this one is also going to be a sprint, and we'll see how much we were able to do in the next few hours. So ideally our goal would be to assemble the upper body, so the aluminum profile and the shoulder of the robot and the arms. So that would be ideal goal for today. Hopefully we're able to show the assembled upper body by the end of this live stream, but yeah, it's a sprint, so we'll do as much as we can in the next few hours. So yeah, let's get started with it. So I'm gonna start off with removing these supports, understanding how the joints are built together. Based off on that, we might even have to change this actuator a little bit. I'm assuming we'll need to change this actuator a little bit. So yeah, let's check. First of all, I'll just bring some parts here. I think I will have to use the good old double-sided tape for this as well. So let me try and make a quick soldering sort of station. We don't have access to all the perfect tools right now in the lab. We are making use of the things we have available in the lab to put stuff together. So ideally, if you are planning to build this robot, and if you have
anything from here,
yeah, I'm gonna also need this plier. If you have some free time on your hand to make sure you order everything the right way, you have the right wires, the right components for everything, it will make it way easier to proceed with the assembly part. I think so. One of the actuators needs to be assembled in a slightly different way. So as you can see, this is the motor side, and then on the other side of the actuator, we need to assemble these two parts instead of the normal rings. These are just normal rings.
Yeah.
Instead of normal rings, we need to assemble these two rings like this.
Gotcha.
On the bearings. So on one of the MC612 actuators, I'm assuming right now that this is the M612 actuator. Instead of these normal rings which are on top of it, this one, I would need to add a layer of these rings like this, something like this. Yep.
Can you pass this?
Something similar to this. This is how this part would need to be made. So I will have to unscrew this and join this again.
Can you pass the scissor?
Yep, there you go. But yeah, first of all, I'm just removing the supports. So we're using the good old double-sided tape once again to solder everything together. The double-sided tape has been the most useful tool so far that we have used on this project. Hackerspace, making use of any and all tool available. I am gonna attach the double-sided tape to the slight edge of this mount. On Temu or on AliExpress, you can find really good quality soldering stations. So they have all the latest bells and whistles you need for a soldering station. They have big magnifying glass as well, so if you are doing soldering on very small and precise components like this, you can look through the magnifying glass and it makes the process a lot more easy. That is what I recommend you to get if you have the time. Temu has all the good tools.
Yeah,
all the good parts. Also, if you are following along with this journey, I want to reiterate that the wiring, the color scheme for the wires is different in our case. This is not according to the documentation because once again we did not have the 20. Can you pass a nail cutter? We did not had the 24 gauge wire, and we are using a 20 gauge wire. So we are having to modify the wire a lot, as you can see. Yeah, but it's really easy to make the connections in accordance with their guideline. They have provided sufficiently detailed wiring diagrams, so it's relatively easy. It's just that we did not have the exact same color codes available in our 20 gauge wire, so we had to use different colors. But it should not be a big hassle. It should be relatively easy to set up. Once again, all of the details are available in the documentation, so it's just kind of a time-taking task. There's nothing too deep or technical about it. It just takes time to assemble all of these together, and just following the guideline should be enough. You will have an assembled robot in no time. So as it turns out, I tried to make these wires smaller, but these connections are still too big for the solder pads on this motor controller, so I'm gonna have to further cut them down to size. It's remarkably small. So let me try to make a few adjustments. There's one small suggestion. So whenever 3D printing a part, it's always a very good idea to remove the supports as soon as you possibly can after the 3D prints are finished, because the part is still warm and they easily come off. But if it keeps laying around for days, as this was the case, the parts become cold. In that case, it becomes very difficult to remove the supports. So it's a good idea to remove the supports as soon as you can. Once the parts are printed, it very easily comes off. So I'm having slight difficulty removing these, and it's just taking extra time as well. On the news today, the Japanese news, they're saying there's a storm about to hit the Tokyo area.
Yeah, typhoons are always a problem.
Here
Every
in
now
Japan,
and then,
yeah.
we face a typhoon here in Japan.
Yeah, it's kind of like an island nation, so the weather is very dynamic over here in terms of typhoons, and I think I'm gonna have to try with the 40 watt soldering iron. It's gonna be raining here for the next 1 week or 1 week and a half, and I'm pretty sure the weather after that will become quite cold. Summer is ending as well. It's almost time for autumn here in Japan, and combine that with storms and rains, I think the weather will get cold by the mid or end of this month here in Japan. We added some background music this time around in this live stream, and there was a lot of ambient noise in our previous live streams because we have set our microphone right now to or record or pick up voice from all directions, and so that's why there was a lot of ambient noise in the live stream. So hopefully the music now fixes that issue. We're gonna see how this live stream turns out. If soldering this is gonna be a problem, I'm not gonna lie. Yeah. Is it too small? The parts are too small? Yeah, these solder points are really small. So I'm gonna have to get really used to this. So while the solder iron is heating up, I'm gonna bit more double-sided tape at the bottom, so the base is nicely tucked in its location, and there are not a lot of vibrations. By the way, we bought a 3D printer grinder sort of from Temu. Where's that part? Is it here somewhere? I think it's supposed to be in here somewhere. I think it was outside somewhere over here. Here it is. This is a sanding tool sort of for the 3D printed materials. Or this is called. So for the 3D printed parts. However, it's very weak. The motor inside is very weak. So we're thinking of purchasing another one, a bit more strong one this time from Temu. So I'm gonna be using this to clean the parts for now. Let's see how this performs. I'm not too optimistic about it though. The motor seems to be very weak. By the way, I think the music covers up for quite a lot of the chat. Yeah, the lo-fi music is it keeps looping. So it's a really good addition. Yeah, it covers for all the pauses in between the chats. Yep. As well as the experience improves a little bit. Yes, the overall theme sort of the live stream. Man, it's really difficult to remove these parts once they are cold. The small patches of the supports which are just staying attached with the part. I think I am gonna have to really zoom in. Yeah, zoom in and on this to solder this. So I think you handle this part over here, or maybe we can move the camera slightly to this side, and let's move this a bit over here. Everything. So I am much more closer to the things I'm soldering. Okay. And then I'll show the end result when I solder it successfully. This one's over here, and here I am removing the supports from this part. I don't want this part of the table to get too dirty, so whichever supports I remove from here, I'll just clean the table afterwards. In other news today, if you guys have watched UFC, the main event was like really good, and especially the main fight. If you've seen it, you know, it was just crazy. He absolutely demolished Ankalaev. And the funny, what I still cannot wrap my head around is that it was a title fight. Yeah. It was a title fight, and he just completely eliminated the person as if it was the easiest challenge of his life. It was supposed to be a title fight. Yeah. But he just made it look so easy. Unbelievable. Pathan is a really good fighter, and one can easily see why he has such a good fan base. He totally deserves it.
main event was also pretty good with Mirab.
Yeah. Sorry for the silence, guys. I am really having to lock in for this soldering. It's like
Really precise.
yeah, it's like really precise and
Actually,
yeah, I need this.
Okay.
It is really precise and I am locked in like fight or flight mode trying to get it right.
It would be good if you can do it in front of the camera though, even if you have to log in from the side a little
Okay,
bit, because
just a second, let me prepare this and then we can move the camera here.
I think I will have to sandpaper this with hand because these are really bad. These holes. I will remove these ones first. So guys, over that side, close to here, just about here, there's soldering going on for the electronics components for the wires, and I am removing supports from these parts before assembling the upper part of the robot. So for that these are necessary, so I'm just removing supports from these, making sure they are clean before assembly. I should have removed these supports a while back while they were still warm. It would have been very easy, but I just delayed removing them and now it's a bit difficult to remove these supports from here. As you can see, there's small fragments and small parts which are being left over here. So I'll have to use sandpaper later on or remove them somehow, clean this component before making the assembly. This as well.
I think I will have to change the. Let me try with this arrow here. Yeah, this one is much better.
Okay, almost clean.
So Reg just asked something in the chat. I have a question. Does the PLA get hot with the motor? Is there a risk of melting? Yep. So let me try to show that in this live stream. Reg, you have a really cool avatar walking around on the live stream. This is actually the first time we have also seen this happen. So we were waiting for someone to comment on our live stream, and you are the first one. So thank you so much for commenting and showing us that the plugin we have installed it actually works. So the PLA you need a lot of heat to melt it. So generally, I have this soldering iron over here, and if I just attach it over here, you're gonna see how quickly it melts. So as you can see over here, it left a big mark over here. But the heat that the motor produces, it's not enough to melt this PLA. If you are worried about the motor getting hot, if it's handling a lot of torque, it's not gonna get as much hot compared to this, like what we're talking about here with the 40-watt soldering iron. So you're not at a risk of melting PLA. However, I would absolutely recommend you to go with ABS if your robot is gonna be out in the open space. So for example, if you take PLA, the robot you've built, if it's made entirely of PLA, and let's say you take it outside on a hot summer day, let's say it's about 30 degrees Celsius, around that temperature. If you keep it there for long enough, your PLA is gonna melt like this piece of paper. It's gonna become totally flexible and it's gonna break apart. It's gonna like fall in on its own weight.
Yeah, on a hot day, if it's in the sunlight for a while.
Yep. So this PLA, the sunlight on a hot sunny day, it's the sunlight is the biggest enemy of this PLA. You don't want, if you want your robot to be operationally stable in outdoor environments, you have to do a lot of weatherproofing, and you have to use PETG or battery at ABS for that.
Yep.
But to answer your question once again, the heat from this motor, it's absolutely not enough to melt
as well as
you
can see that they have made these open spaces for the air to flow through, so they have left opening for the heat to dissipate. It's not that big of a risk with this motor. Yeah, thank you very much for the comment, as well as the little avatar that's now moving below the screen.
Yep, it looks so cool. The avatar also has this cape thing going. It's wearing this. It's like wearing a red cape, and it looks like that cape from when Guts in Berserk had that cape when he was a part of Band of the Hawks. A Berserk reference here. By the way, I absolutely recommend you guys to read Berserk manga. If you are a fan of anime or not, if you read manga or not, Berserk, it's like a universally...
Yeah, it's one of the best stories in, at least we've seen in any season, movie, anime, in any of that. It's one of the most...
Yeah, you can argue it's top 3 to top 5 fiction pieces written of all time.
Yep. It's really great. Alright, this part is clean, as you can see. This one is not very much clean. I hate the way it looks over here. There's still supports latching on with this part. I need to clean it before it's ready for the assembly.
Latching made me remember that song.
Latching on.
Yeah. I wish
what a nostalgia,
music, but yeah, we even if we play a copyright music during the live stream, even during the live stream session, the stream is gonna be pulled down by YouTube. Their copyright system is really good.
That song, Latching On, it is at least from the video where we saw it, it is supposed to be copyright free, but you cannot take risk with these things. You never know.
We're not gonna be taking any risk like that.
But it's a good song and a really nostalgic one as well.
Yeah, the music we are using right now in our live stream is from Epidemic Sound, and
that's how we feel comfortable sharing this music in the live stream, because we do if you have a subscription to the Epidemic Sound, you have a license to use all of the songs that the streaming service has. Rich commented again, thank you for these wonderful tutorials. I think you are only ones who do this. It allows us hobbyists to be able to create the robot cheaper. Yeah, thank you for that comment, Rich. I really appreciate that. And yeah, we're building cool stuff like that all the time. Let me show you something else, a little sneak peek of upcoming video. I think you're gonna really like it. An upcoming video. Reg. Sorry, I'm messing up your name. In an upcoming video, I'm making a tutorial on how to build these action figures with microcontrollers. So there are embedded components in there, and we have made our own custom PCB for this. Let me try to see if I can find that around here or not. Yeah, it's there if you can grab it. So I have built 3D printed this action figure and made this PCB. So this PCB goes inside this stage sort of thing over here. So if I can zoom out a bit with the camera, okay, now it's better visible. So this stage, as you can see, it can be opened, and inside we have some electronic components. Yep, so as you can see, we have a lot of electronic components in there, and this character itself is sitting on a gear. And now you can see, if we turn this on remotely, we have a potentiometer over here that can change the speed of this motor we have attached in there. So this action figure is able to rotate, and you can place it on a desk, you can place it on a shelf or anywhere. And then we also have, this is by the way wiring. In terms of wiring, this is independent from this part. Then we also have a display over here, and this display is able to fetch any publicly available information from the internet and display it over here. We're using this small display because of the design, but you can use any display with it. And I'm uploading a whole tutorial on how I painted this, how I 3D printed this, how I made this action figure using AI and then improved the model in Blender. So I'm making a tutorial on this as well, and that's gonna be coming out on this channel really soon. So yeah, we are making projects like this all the time, and we figured just why not share this with other hobbyists and enthusiasts out there, so we can build something cool together. And I would absolutely love to see what kind of projects you are working on as well. And yeah, so it's all for the open source contribution. Whatever knowledge or skills I have gathered over the years, I love to share them online. And we're gonna be doing a lot more of these live streams, documenting the process of how we make all of these things. And if you are working on cool stuff, I would really love to see what kind of stuff you are working on. Another comment from Reg. Wow, very cool. Yeah. I don't think it's really cool, but thank you for the compliment. If you think it's cool, I guess that it means a lot to me. We have some other stuff lying around in the lab as well, which we are gonna be sharing in future live streams. I'm gonna be making a tutorial on how to build a custom PCB as well. So this PCB is the high voltage area, where if you need 24 volt to provide to a project, you can get that from these pins over here. Then we have 5 volt signals over here, power signals specifically,
and a lot of GPIO signals pins over here, and I'm gonna be making a tutorial on how you can make a custom PCB with your branding on it. So as you can see, this has our branding on here. I'm gonna be making a tutorial on this as well, and a bunch of other cool stuff as well. But it's not gonna be limited to electronics only though. I'm also gonna be making some tutorials on animation. We got another comment. It's a robot for my son. He loves a lot of robots. He's autistic. I want to make these robots taller, 5 feet. That's so awesome. That's so admirable. And yeah, if you can make something like this for your son, maybe it will spark his curiosity. And if you can explain the process to him, because honestly it's not that difficult, it's just a small learning curve. Maybe your son will also start working on cool hobby projects like this.
I have NVIDIA Jetson Nano Super that I want to implement. NVIDIA Jetson Nano can be used, Raspberry Pi, Jetson Nano, all of these can be used. As for making the robot taller, there is a Berkeley Humanoid Light version, the one that we're building, but I think there's a taller version as well. I'm not sure about that though. This humanoid robot is just one open source option. There's other as well. For example, K-Scale Labs, they also have their design fully open source along with the parts and everything. So I don't know, there's a decent bit of community around this robot, but I don't know about the community around that robot. But it's their robot is much bigger. It's like human sized robot. So there's many options available.
If you want to make this robot taller, you would need to, you can make the current existing model longer, but you would need to learn a bit of 3D CADing and stuff like that in Fusion 360. Then you can maybe add some structural support, like maybe using aluminum profiles like these. So you're gonna be using these aluminum profiles as sort of the spine or the central structure that will hold the robot together, because the robot already as it is, it weighs a lot. Even if you're watching the tutorial, they are holding this robot by using some straps on its shoulder, and so the robot is not able to walk on its own weight yet. So you're gonna need to add a lot of structural support so the robot is able to stand on its own. Yeah. But it's definitely possible, but you will have to tinker around with the design in a CADing software like Fusion. And that's the awesome thing about this, is because everything is open source, you can work on a design, you can give back to the community, and maybe other people are also interested in that. They can help you improve the design as well.
I think if I want to make it bigger, I have to retrain it, or maybe I could make the torso taller. So yeah, definitely making the torso taller is one way of making it taller, but your point is completely valid. You will not be able to use any open source sim to real models, because other people, when they have uploaded their models for maybe the robot walking or doing some activity, they would have trained that simulation according to the size in which this is available in open source. So if you apply that simulation model to your robot, because of the size difference, it will not be able to walk. It will not be able to effectively imbibe that.
And also making only the torso larger will mess up with the proportions of the robot a lot. So like if you are using some sort of simulation,
software for training the robot, you will have to account for really short hands and feet of the robot and the overall weight distribution of the robot. And the open source community generally will head in a separate direction than what you are building. So you will have to train that robot on by yourself. You will have to maintain and improve that design by yourself. So what I recommend is simply you can scale up this design, or you can add a little bit of extra aluminum extrusions and 3D printed parts just to add a little bit more gaps between the joints. There's one thing I would like to confirm though, which is that Berkeley Humanoid Robot might have a normal sized robot, bigger sized robot as well. So there's the light version and there might be a bigger version as well. So if there is a bigger version available, that solves your problem by default. I would first of all like to look into that. Otherwise we would need to maybe use, just like you mentioned, maybe just make the torso bigger, or the body of the robot, the aluminum profiles, while keeping the hands or legs similar size, just the center body part bigger using bigger aluminum profiles. So there's multiple options we can look into. Awesome, thank you very much for the comments. The weight will definitely change the balance from simulation to real. So
Yep,
the software side would not work.
Yeah, and lastly, I would also like to add that if you have not built this robot first, the robot you are thinking of building, like a bigger size of it, it will most probably not turn out perfect in the first attempt. So first up, if you have a 3D printer, you might wanna try assembling these actuators and joints as it is, and then maybe making one arm. And then when you're feeling confident with that, you can open up the STL files for the arm of the robot, and you can start playing around with these 3D printed parts inside of Fusion or Autodesk Inventor to scale up the parts to a bigger size. So I would recommend only starting with a single arm or maybe even a single joint, scaling it up, and then trying to make it work.
Yeah, but thank you very much for the comments, Reg. Alright, it seems to me that this part is also clean now.
So a little bit update on what I have been working on. If I can move the camera here on this side. So I have soldered the voltage wire and the ground wire so far, and because these wires are not the right gauge, they are thicker than the 24 gauge wires that were required for this. I am having a little bit of difficulty soldering them in its place, but so far I think I have done a decent job of putting these two wires together. Let me try and bring it close to the camera. So yeah, if once again, if you don't have the right sized components sourced, it's gonna be difficult to solder, but I have had a lot of soldering experience in the past, so that's why I'm able to solder a thicker sized wire over here, but still it's like a pain to do. If we had 24 gauge wire, it would have made things much better. So yeah, I'm gonna be going back to soldering these, and I'm gonna show once I solder all 4 of these wires. We have 2 more signal wires to go.
You can move the camera back here. So over my side, supports are almost all removed. Just need to take out these small holes over here. With that, these parts are ready for assembly. What I'll do afterwards is I'll disassemble this little thing over here, this actuator, and I will reattach it with these parts so that way it's ready for assembly with the aluminium profile. So just keep removing these parts.
By the way, once this project is over, or if we put this project on a pause, we are also thinking of doing animation live stream. So this channel is not only gonna be all about electronics. I also really love 2D animation and 2D illustrations, and we also watch a lot of anime. So if you're into that, we can also do some fan art live streams or illustrations, but we're gonna be doing those sort of live streams as well.
By the way, it's really funny to see the character appear at the bottom of the live stream with the comment.
Yeah.
I wonder if the comment, he spelled out the comment as well. But of course we're not able to hear it right now. But maybe later in the live stream we will be able to. Once the comment comes, it appears on top of the character
As a bubble.
Yeah, as a bubble.
Wow.
It did appear.
Yeah. Then I think
He probably the character spelled it out.
Yeah,
as well.
spelled it out loudly. Yeah.
This is such a cool feature.
Yeah. Yeah.
It's one of the things I really love with indie developers. They make such cool extensions with software, hardware, whichever their domain is. But it's such a fun and artistic way of creating something, making it more fun for the live streamers. This project is similar to the one that we were doing last year, the Lo-Fi AI one.
Yes.
That one also involved ABS, API, YouTube integrations. It's similar to that one, but it's so sophisticated and fun, and it's just a digital product. So like he's just put it up on stream, and forever people are just using it. Even with robotics and software, as one comes to know more about the niche, more depth about what kind of products or things are out there, I think one is able to come up with fun ideas from which he can create digital products out of. It's in every niche, of course, digital products.
I just have one more signal wire to go, and then I will be done with the first motor controller. We're going to be testing this with the continuity test just to make sure there is no shorting going on. I think I've got somewhat of a hold of it now, but I would be lying if I say this is not like a little bit difficult or intimidating. So I have done the soldering now, and let me make sure nothing is short, and then I'm gonna bring it closer to the camera and show it to you guys.
No way, this is so small, the soldering.
Yeah,
There's no way there's not short.
Okay, here goes nothing. No short on this end. Let's check on this end as well. No short whatsoever. Awesome. So the first motor controller is done at last. And these solder pads were really close together and it was a real difficult job soldering them. Now I'm gonna solder the wires and let's move on with that.
Let me take a photo of this one. Okay, good. Let me use it later on. Do we have a brush or something to brush these parts off of the table here?
I think we might have some paint brushes. I'm not sure though. You can check them. They're very in the lowest drawer. Otherwise, you're gonna just have to do it with your hand for now.
I'll do it with a tissue.
And let's solder these wires now on here. I think one of us is gonna have to hold it like this in place. Yes, I think. Let's check again for the connections that we have to make over here. Okay, so they are soldered on the bottom side.
We also have to place the order of this presence module once again.
I think I've done that, but I will have to double check that if they have accepted the.
No, if you've done it already, then it's great.
Yeah, I think it mentioned it's arriving on Tuesday, but I will have.
Yeah,
to
so
double
there's a module that was recently released here in Japan. It's somewhere over here.
It's here. I've got it.
So there's this module which Sony has recently released in Japan, and they claim that it's so precise it can measure the exact rotation of the Earth. So at any time it can very precisely measure the rotation of the Earth, and for that it can be used in many applications, in cars, GPS, airplanes, navigation systems. So it's a pretty precise equipment that they've created. It's 1 2 3 4 5 6 7 8. It's 16 individual IMU sensors in total combined in this one chip. So it's very accurate according to them. I have still not tested it yet, but this is Sony's presence device. It's only available here in Japan for now.
Can you hold it like this? Like this. Both of these.
Just a second.
Yeah, on top. Yeah, like this. Be careful, the solder might jump out of its place. Just insert it in there. It should be stuck in there now. We're gonna do the same for. Oops, I got it from the wrong angle. Let's desolder and bring it from the inside. Okay, and yes, let's try and bring it from the inside this time. So if you can hold it here in place. keep your hand at a distance. It's gonna try and jump around. One done.
These wires are massive. Does it go like this?
Let me see.
The
Just a second.
But the thing is that BLDC motor can be like this or like this. We don't know what, or it can be like this.
Yeah,
Or
let's
this.
just solder it in one orientation first. We're gonna have a look at it later.
Yep.
After this, okay. Now I want you to hold this in place.
Just put it a little bit over here so that it's visible. Just a second.
Same for the last one. Look at the wires are really hot.
Yep, this black one is as well. It's very hot.
Here, a little bit away from this chip. Yep. This is good enough. So it should hold it in place like this. Okay, let me double check the orientation of these wires now. So it is gonna go like this, bam, on top here, and we are just gonna tape it in place, and this is what one motor controller along with this motor looks like. So we have yet to solder the CAN wires as well. Those sections on this module are also really small, so it's also a real pain to solder these, but thankfully for that we have the smaller wire lying around. So the CAN signal wires are gonna go over here, and I'm gonna solder them in a bit.
I will now check the joint for this one. So I will need to disassemble this part, right part over here. In this one,
So let me now double check the orientation of the motor. That is this way around, and these
interesting. So how much do I have to remove this? That was for the leg, I guess. For the top part, it has to come off here.
I think it's a bit difficult to like figure out the orientation of this, but we will simply have to like replace it with a negative in the direction negative in the code if the our wiring direction is off, I think. So let's move forward with soldering the CAN wires, and after that we're gonna be good. Yeah, these wires are causing a lot of trouble. They refuse to give up because they're not the right size. So they're like trying to push into each other, and I am scared of a short circuit here. I'm gonna double check this after applying the CAN wires. So these are the 30 gauge wires that we are gonna use for the CAN signal. So let's try and first open this up. I think this one is the black one. Yep. So we're gonna be using this. This is a really thin wire, so it's gonna be a really easy soldering job. With this, we also need yellow and green wires. Because this material is totally on spot, this is the right color scheme and the right wire size. So we're gonna follow what is mentioned in the open source documentation. So we're gonna be using the same colors and the same wires for the CAN signal. Let's give it about this much length. I'm gonna keep the length same for all three wires. Let's also grab some green wire for the same length. Do the same with the black CAN signal wire. Let's cut it. I'm gonna put these three to the side now, and I am gonna use a tool to expose the copper part of these wires. So let's try and see if it fits. Yep, so the copper part is exposed over here. I'm gonna do the same for the other side, but you need to make sure you don't cut too much, otherwise the wires are gonna move around when you are assembling the robot, and there's a risk of the wires getting short over here. I wish all the wires were this small, but unfortunately the wires that carry a lot more current, they need to be bigger in size. But we need China to make another breakthrough, make all the wires in the world this small, so they're easy to solder. Or for the tough soldering situations, we can train our humanoid robot to handle that part, so we can watch Netflix or some anime. We can watch Kaiju number 8 while the humanoid is handling the soldering tasks for us. Do you guys think the humanoids and AI will make human beings generally more less motivated, generally more what term am I looking for here? Generally more
fulfilled.
No, fulfilled is not the right term. Like not willing to work.
So the quality of life will improve or not?
No, I think the quality of life will definitely improve, but the question I'm asking is about the motivation of human beings to get up in the morning, do stuff, because humanoids will be doing this soldering. Let's say in an ideal sort of
yeah, but the thing is that humanoids cannot solve that problem for humans. Humans have to solve it for themselves. They need to figure out what they enjoy doing every day. So like that's a problem they have to solve for themselves.
So let's say they enjoy doing soldering and their workshop tasks.
Yeah.
But now the humanoid is handling that.
but they, if they enjoy doing that, then they don't do it for money. They just enjoy for whatever their
No,
craft is.
they
or
have to
it's a-
provide for their family. Like, I mean, it's a
No,
part
but-
of it.
No, but the thing is, enjoyment and money are two different sort of. The effort to combine both of these is sort of the effort of entrepreneurship or whatever YouTubers or people do. They try to make what they enjoy into their career sort of. Like that's a whole arc every person goes on. But what someone enjoys doing in it of itself is different from money. And to be honest, I don't think that most people who do job do enjoy where they're working. They're just doing that because they have to make money somehow. Like that's I think the situation with most of the people. Not everyone is doing what they enjoy and really look forward to every day. By the way, if you can look at this humanoid over here, the thing with aluminum profiles and assembly is that it's an entirely new stage. So in the Discord images that I showed you earlier when they were calibrating all 22 actuators,
Yeah.
all the actuators were like this. So in the calibration stage, what one has to define is that this is left arm, this motor, and this is left arm and place left arm, all the actuators of the left arm there.
We can just
Right arm, all actuators over here, and then calibrate them. And then once they are done, they have to put those parts on their respective, this actuator on that respective position
no.
over here.
Let's say we don't even want to calibrate them. Let's say we just add a
We'll
paper tape on them, and we just mention this is the shoulder, blah 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 blah, and then we can calibrate them later while it's on there. We can try and calibrate it later while it's on there.
Can we? All right.
Otherwise, like we once this is soldered.
The problem is
We will have to stop everything after soldering these
The-
components.
the problem is
Yeah, so these wires are really messed up. I'm gonna try to improve this soldering in the next one, and then I'm gonna come back to these. But this is one unit finalized. So let's also like attach it over here with a tape. If you can grab one. This is like ready to just be attached, and this is the final
okay.
answer.
This is on C612. Yeah, this is on C612 actuator, the bigger one.
Let me rotate the CAN wires so they are easier to manage and they move around. And then we're gonna have to braid these wires, which I totally don't know how to do. Let's just call this braiding, and let's put it on here, and let's apply some tape, or maybe a rubber band will work. Can you grab tape?
Which one?
I don't know which one we're gonna use. Ideally, it should be light. Yeah, I think
Masking
this one is pretty light. We don't have a masking tape. That would have been much better.
Every lab needs a masking tape. Every lab needs a whiteboard, one very important, a whiteboard and a masking tape.
Yep.
I think is this good?
I don't think this is good enough, but this is good enough for one side. We need one more this side as well. And let's just call it like wow, so pretty. Add that wow sound effect. This is one actuator
Wow.
done. It's ready to be calibrated, and we need emotes and we need to add those sound effects for that's what we're gonna do next in the live streams. So this one of them is done, guys, and let's place it to the side. Now this time I'm gonna try to improve this section because the other one it was looking really fishy, and there is a chance of some wire going short in there, so I'm gonna try to prevent that from happening in this one, and after soldering everything I'm gonna move back to that and fix that issue.
I guess I can start grabbing the aluminum profiles and then assembling it just like that. The problem is if there's some issue with calibration or later on uploading the software or anything, we will need to disassemble it once again, and that will take a bit of time. But for now, since we have to have upper body by tomorrow ideally, so the goal we had in mind was just a stationary upper body without any calibration, without any software tinkering, without anything, just like an upper body
an assembled upper body.
Okay, yeah, I can go for that. Where's the aluminum profiles? Finally, after long last, we are opening the aluminum profiles. Unboxing these so we can start the assembly part.
You can like really see how much we're trying to sprint our way through this when you can see me using a nail cutter to clip these wires. Try to make them work somehow when they're like so big.
Yeah, we're really sprinting through this project. So even this live stream, it's I think our fourth live stream. It's our fourth live stream. So 4 days of doing this, and we have assembled these many actuators, and we're just trying to move towards assembling the body. We do not have all the components, unfortunately. We do not have the CAN USB still, which is very important for completing the connections, as well as we do not have all of the bearings for rest of the actuators, but we're trying to sprint with as many components as we have. Are these the only aluminum profiles we have? Do we have any other aluminum profiles?
I think so, yeah. We had more than these. Yeah, they're below here.
Bring them out. Bring them out. Ta-da. Oh yeah, so these are the ones which are needed, you can see.
Oh,
yeah.
Okay, gotcha.
These are the ones we need.
I'm gonna grab the ground wire.
Why do I feel like even they're slightly longer? Check the proportions.
Yeah,
they look even. Are there any more aluminum profiles?
I don't know. You can.
I think so. There were 4 of them in total, I think.
Yeah, I think it's time to bring the flux out. It's getting oxidized.
Found the right ones. This is exactly the right size that we need. So we have 1 like as well on our video.
Awesome. Whoever was there, thank you so much for leaving a like on the video. Helps a lot. We're just starting out with this live stream sort of journey. We're figuring it out as we go. I think I'm gonna have to start using flux. Interesting, I also have a video on flux, the AI model, but I'm talking about a different flux. This is a soldering flux. I have not used this so far, but here this module, the solder wire on this and the solder tip is getting oxidized, so I think I'm gonna have to try to apply a little bit of this flux on top of it and see if it improves something. Let's apply it over here. So the packaging is really nice. It's like a nail polish almost. Wow, it improves it a lot. I really need steady hands for this. I'm gonna have to bring the camera closer so I can move much closer to this. Let's try and do it this way. I think it looks pretty nice. Let me bring the camera back up and let me pick it up and try to see if there is anything fishy going on. I'm gonna have to check for a shot here once again. Yep, so we have a short here with the neighboring resistor, and the resistor is almost in there with the point for the wire. Okay. Now it should be good to go. Let's try and check for a short again. Inside we need to enter this part. This part needs to go inside. Like this. Okay. Let me double check this on a separate one. So it's always gonna be short with this joint. Let me double check it over here. Okay, so this solder joint is perfect. It took a lot of tinkering around to make sure this was okay. And yeah, this solder flux, it really helps with putting these on. So I'm gonna apply some of it over here as well. And let's add a little bit of solder over here. I'm gonna have to slightly desolder this because it's a big blob and it's gonna merge in with the rest of the parts, and we don't want it to do that. Okay, let's try giving it another go. This much should be good. Okay, looks good. Now we are gonna add a little bit over here.
Hassan, these are what, M3? These
You can open them and check them.
vernier?
Yeah, using vernier. Here we have vernier. I need some tweezers. Where do you know where? Yeah, this one will work.
It's sort of 3.3 or 3.4. Is it like M3?
Yeah, should be. Yeah,
Yeah,
based on where you're measuring, it should be about 3.
that's 3.2 mm.
Yeah.
Why is it always coming out to be 3.2 or 3.3? I mean, it's supposed to be 2.9 or something.
Yeah, but M3 should be able to nicely go in there. You can check. Yeah, I think this one is M3. I think. Check it in.
It's loose, which means this is M4.
You can check this as well.
I think this one will fit.
That one.
Yeah, this one fits.
I think that one is M4.
Then this is M4. Let me check the other ones that we have. They're smaller, the same size. So why? Oh, I think these are smaller ones. M3, yup. Oh yeah, these are M4. It's mentioned. These are not the ones that we need. These are the wrong ones. I'll just put them back. Open up the M4 one or M3 one.
Yep, so it gets easier the more you do it, this soldering, these connections, and especially if the wire size was thinner, it would have been much easier at this point. I have gotten a lot used to it now, and I am on the second one now. So I've made all 4 connections. Let me pick it up and let me try and zoom in and show it to you guys. These connections, once again, yeah, it came off loose, this wire. I need to like really push it in there. I will have to add a bit more solder wire over here, and then we should be good to go to make the last connection. Yep, it messed up. These connections got messed up again, and I will have to remove the solder from here and redo these connections. I think if we had that magnifying thing with the solder station that you can get for very cheap on like Temu and places like that, it would have been much easier to do this as well, because this is really narrow window of placement for these wires. Very small section. So these are right next to each other, so you have to make sure to make room, to leave room for the next wires that come right after the one you have attached, and while doing that you have to make sure they don't sort of merge in each other. I'm gonna bring it a bit closer so you can see the soldering that's going on. Yep, so we're done with this these 4, and I know the blue one and the yellow one really look like they're soldered together, like they're short, but they are not. That's how close these connections are. So I am gonna place them to a side. I think let's just do this first of all for all of these, and after that we can move on to attaching the motor wires and for the CAN signals. I can attach them while doing this. the CAN bus, but for the motor connections, let's do those later on. So I'm gonna cut
Yeah, we can do them
a
later
bit
on.
of wire for the CAN once again. One, 2, 3, 4, 5, 6, 7, 8. So we need 8 more of the CAN signal wires. So I'm gonna prepare them in advance. And these CAN wires, they are really thin, so it's really easy to solder them onto these joints. They have really nice section on the motor controller for them, and they sit in really nicely. And there, if you expose the copper enough just for soldering, there is no risk of any short connection between the different CAN wires. So this section of wiring for the CAN signals is not that troublesome.
Over here I am connecting this part with aluminum profile, and once that is done I am going to disassemble this and attach it with the aluminum profile as well. So that way the assembly of the upper body will begin. For the assembly we almost have to open up all of these.
Why?
Because there are parts of the arm like this,
Yeah.
upper arm, lower arm, instead of like this. Do you remember this part that was in the middle where we put
Yes,
bearing
yes,
here? So
yes.
instead of that we need to replace it with this.
Okay.
And the part of the body next to that attaches over here,
Okay.
all of the arm. So that's why I was saying we'll need to open all of these and assemble the arm. That why that was why it was sort of the next stage.
Yeah, but it's gonna
I
be.
don't. Yeah,
We're
I
gonna
guess.
see how much the hot glue has solidified in there, because it's gonna be
That's gonna be a huge.
it's gonna be difficult to remove them now.
Yep.
I am now preparing the ground, the black wire for the CAN signal, and after that I just have the green one to go, and then we should be able to solder them all to these motor controllers that we have laying around. So once again, it's a lot of repetitive work. Most of the design, once you get the hold of the basic design, like how to assemble a single actuator and what sort of wiring you need to do for a single actuator, it's just a repetitive process for the rest of the actuators. And it's probably the same for legs and the upper body and the lower body, but we are only working for the upper body now. I think you can try to disassemble the 6E12 one that we made,
Yeah, and then
then try to put it on the shoulder of the robot, and I just want to see if it's easy to remove
the motor.
yeah, if it's easy to disassemble the actuator now that we've used some hot glue in there. Because yesterday, yeah, everything was like so fresh. I don't know how much the hot glue, what kind of effect it's gonna have on these actuators. Yeah, I uploaded the video today in which I showed the method of using the hot glue to attach the actuator together, but I did mention in text format in that video that it's not the right way to approach this. Yeah, because we do need to disassemble that actuator later on. So yeah, using hot glue in there is not a good idea. If you can, you should arrange the proper hex stand, the right size hex stand for the pre-printed part. Yeah, so assembling, soldering these CAN wires, it's relatively simple task to do. It's very simple compared to these wires from the encoder. The wires from the encoder, they are a mess, like they are really difficult to put on here. Now I am gonna first attach the ground wire for the CAN. It sits nicely in there. Next up, we are gonna attach the green one. Gonna clean up the tip of the soldering iron and put it in there like so. Lastly, I am gonna pick the yellow wire and I am gonna put it in its location as well. So okay, so this one is also done. Now I'm gonna remove this now from this double-sided tape, and I'm gonna put it in its I'm gonna put it to a side now, and we're gonna move on with the next part. Now we are moving on to 5010 encoders, and the process is exactly the same for these ones as well. So I'm gonna grab another motor controller, this one, and I'm gonna place it over here, and let's try and see what adjustments we need to make to put these wires in there. Okay, I have gotten a hold of it now, so I think I don't need to make these any short. Ideally it would help, but let's try to do it without that because it's really time consuming. I'm gonna clean the tip of the soldering iron, and I'm gonna apply some solder over here. You know what, a little bit of flux will help in this case. So be sure to have everything related to soldering ready before you move forward, because it gets really difficult if you don't have the tip of the soldering iron is oxidized and it's not picking up the solder at all, and this space is already really narrow, the space we have to work with. So having soldering flux really solves the issue. It makes it way easier. Okay, I have melted it and I'm gonna attach the ground wire here now. And it looks good to me. Let me try to a little bit more. Okay, I just dropped it. Let's try and do a short connection test, because it looks like it's shorting with the resistor parallel to it. Yep, it's short with the resistor on the side of it, so I'm gonna have to remove it and go back at it again. The solder flux, it really spreads the solder all over the board, like wherever it can find its way. So you have to be careful with using that.
This will be a bit difficult to do with.
You can just first
Disassemble the motor and attach these.
no, you can just thicken the these screws by the drill, using the drill first up.
No, would that solve the issue? I'm not sure.
What's the issue?
The problem is these are M3 by 8, and the 8 is not enough length for it to go down.
So
and
you can grab M3X bigger size.
M3X, we have M3X15.
Yeah, you can try with
Now
that.
the issue with that is it's too long, such that the part, if it's like this,
Yeah.
it bends because the length is just, it comes up on the.
So you might try looking for M3X10 over here. We might have those somewhere lying around in the lab. Look, what size is this? Check it.
M3X. Yes, I think we have M3X10 at our lab. At the end of the day, all of the parts that we have lying around in the lab are saving the day. Almost none of the parts that we ordered, especially these screws and nuts and bolts, worked for this assembly.
Yep. This soldering is really messed up. It's difficult to do. Not like difficult, but really time consuming, and you have to be really focused and alert. because the joints, they're pretty much bumping in each other. They're like right next to each other. Yeah, this is like attaching normal sized wires onto like places made for SMD components. They're slightly big, of course. They're bigger than SMD components. They're not like, but this is what it feels like. Perfect. Next one. Today is it is still a sprint, but it's kind of a slow day today because of the soldering. But right after this soldering comes the exciting part. The most exciting part of the project, which is like putting together everything and assembling the robot, the upper body of the robot at least. So yeah, that's why this is the last bit of soldering we have to do before that. So I'm having to prepare these wires because they are not the right size. So right before I solder them, I cut them to size and I make sure the tip of the exposed copper from these wires, it's nice and is small, tiny, so it's easier to put on the soldering joints. These are not going in. The good thing our lab has a lot of different sizes of M3. No, what size are you trying? Are you checking with them vernier?
It's most likely 10, but even that is not going in. I will now try with this one. This is slightly longer, but I think this will fit in.
Wow.
Yeah, this is almost the right size. Not almost, this is exactly the right size.
What size are we talking about? Do we have a lot of those
we do
available?
have. Yes, in our lab we do have.
Yatta! Finally. I have another one ready, almost ready to go over here. 3 out of with the second one I have soldered and the third one I've soldered. I'm pretty confident they're not gonna get short. They're not gonna be shorted anytime soon. The robot can jump around, move, do whatever it wants, and it's not gonna have a short circuit. So I remembered something. Do you know went when we went to a trip in like 2018 in this country, we made a plan with Mark that we can start an electronics channel. And don't you remember that we made a plan of making electronics tutorials remotely from where we are based around the world? And after like so many years,
Do you want me to share the link with him?
and not right now, not right now. I would much rather be it have reached 4,000
Okay.
subscribers than that.
Yeah, makes sense. What is So did we discuss with him to make a combined electronics?
Yes.
That's strange. What electronics even in your mind back then? That's so far back.
Yes, like we were talking about building rockets, rocket engines and stuff like that back at that time as well.
Because that was a really long while ago. I mean,
Yes.
I had not even the remotest clue about tech.
So at
Tech
that
in
time,
general.
in my university, we went there during summer vacation. You grabbed me from there, so I
Yeah.
was already working on electronics and embedded stuff. And
Funny.
they also like really wanted to work on it, like they were interested in it at that time. They did not know much about it, but they were interested in working on this stuff.
That's so interesting. That's really interesting.
Yes, and how like we've come back like almost full circle.
Yep. Life has a really funny way of catching up. So I was mentioning to Mohammed the other day that a person who I used to admire and learn from when I was in university, he actually reached out and watched one of our tutorials. He came to learn
Yeah, we
from our
can
channel.
tell it to you, like we can read it chat. The other day, Alex Berman of all people commented on one of my videos. And growing up, I used to watch a lot of his tutorials, and I was really inspired by his tutorials. Not in a way to like make tutorials of my own, but I got to learn so much from him. Just a few days ago, Alex Berman commented on one of my YouTube videos, and right now when we're doing this live stream, my channel is not even at 1,000 subscribers, and it was the weirdest thing to see.
It's really weird moment of realization. You're like you really do see that life has a very strange. Life is oddly, the world is oddly very small place. And if you get started sooner, very soon you find yourself among other people.
Yes, and the thing is, like I mentioned before, my YouTube channel is so small at this point, and that was the first comment I got from a really big YouTube channel. And for that channel to be someone that I used to admire, someone that I used to look up to, at such a small scale, getting comment from his channel, getting comment from him, it was really encouraging.
I mean, so far this journey has been encouraging overall. In the YouTube tutorials that we make, as well as the live streams, even by this fourth live stream, every one step there's something better. There's either a like or a comment, or even the quality is improving. So we're adding music and other stuff one by one.
Yes, this journey has been really exciting, to say the least. So I'm gonna unbox more motor controllers because I had 3 unboxed already, and I've already attached them. And I'm improving at the soldering. Like the turnaround time has been getting low with each successive motor controller. I'm gonna unbox all of them at the same time, and then I will proceed to solder the rest of these actuators with the motor controller.
Our lab is a mess right now. If you could take a look at our lab right now, every tool, every component is all over the place.
I wonder how much watch time are these live streams adding. We don't have like a lot of engaged in the sense that they watch for a while live stream, so I don't know what the accumulated watch time for these live streams is, but
Yeah, I guess when we it's like when you have hundreds of videos on the channel, it just accumulates over time.
yeah. So 1, 2, and I think I soldered 3 motor controllers. No, did I solder 2 of them, or did I solder
Which one of these do you use to open up these these
what? Which ones?
these heads?
Which ones are we talking about?
I'm gonna remove these.
So this is just like a simple these ones. You can use
Oh.
these for the extras and the other ones for the because 2, 3, 4, 5, 6.
There's one lesson.
Where's the 9th one?
What the
Yeah, this,
actuator
yeah.
here?
Okay. So it has the motor controller. Okay, so we have
Yeah.
2, 3, 4, 5, 6 more to go. So I need to unbox one more. ASMR unboxing of motor controllers for a humanoid. Okay, let's move back to soldering. I'm gonna apply a little bit of solder flux over here, but it makes it in a weird way slightly difficult and slightly easy at the same time. It's like a in a very weird way. I am gonna apply a little bit of solder over here.
There's a lesson for us to not to put this too tightly in, because we're in at least for the foreseeable future we are assembling and disassembling.
Yes, exactly. Yeah, but I'm really interested to see how easily you will be able to pull it apart. I think it should be relatively easy. It should not be that difficult to do. Okay, I have a nice little bubble over here, a solder bubble over here, and I'm gonna try to attach the wire to this. Let's bring in this one. I am gonna make sure the wire is not exposed too much so as not to short it with the other wires around it. Interesting. I'm gonna reduce the length of this wire as well, and let's try and put it in there. This way around. Okay, here goes nothing. Let me try and run a continuity test on this now, because when you're attaching the ground wire onto these controllers, there's a resistor right next to the solder pad, and it's really easy to get it short with the, so I have to make sure. Wait a second. We need it to be really loud, the multimeter, the continuity test. It's really difficult to listen to it. Yes, nothing's short over here. I'm gonna move on to attach the 5-volt wire now. I'm gonna take the same precautions while attaching that as well. So first up, let's try and add a bit of solder over here. Okay, and then I am gonna grab this wire. First I'm gonna prep this wire using the good old nail cutter.
Is it too loud?
Yeah, I mean, if you are doing that, maybe you should bring it in the view of the camera, so there's no like visual and it's visually coherent to what's happening.
Alright, watch this. This one I'll just have to push, I guess.
Be careful not to drop anything on there.
Yeah, I think I'll have to just push all three of these.
Yeah, you can reframe the camera here and there if you want to. Okay, let's put in the voltage wire now. This is the second wire we're gonna attach over here.
It won't come out easily. No, it won't come off easily.
Yeah, so it kind of worked out pretty good. And the motor shaft is safe, which was the most important part. And this one is like locked in. I don't think this hex screw is leaving its place like ever.
Yeah. So you can see that we had to insert some hot glue in there because the size of the hex insert we had was not exactly tight for this hole, so our size was a bit off, so we had to use this hot glue. Now if we want to get this bearing out once again, it would be a really difficult job because this component is attached together with this hot glue. But yeah, this came off nicely. I am now going to assemble this with the aluminium profile.
Yeah, so it's a big relief now. Like all the actuators we have joined so far, it should be easy to disassemble them and place them in the joints and the relative positions we want them to be in. The cycloidal drive is so awesome to look at from the inside even. I am gonna attach more solder wire over here because it's getting really messed up. So I am having to complete almost partially 50% disassemble this entire actuator. Even the bearing part? Yep, even the bearings. Yep, it this connection got messed up again. Now I'm having to remove everything and remove the solder from these pads and start over again. It's a really precise. But I think for today's live stream, that part is more important than this one. About this part, we are really unsure because we want to calibrate this beforehand as well. Otherwise, we'll just assemble it, then we'll need to disassemble it again for calibration and for the software team to calibrate and separate out the motors, and then we'll have to reassemble it once again. And assembly and disassembly, as you can see, are completely different parts. These actuators will become completely different. So it's better to proceed one step at a time. So I think even if we just make all of the wiring connections today with soldering, I think that should be enough for us as an update for today. Sounds good, I guess. Our average build duration is pumping up and down, up and down, up and down. Yeah, no, but it's at 11 minutes right now, and that's extremely ridiculous. The last one was, I think, 4 to 5 minutes, I think. Yeah, and it's our 4th live stream only. Yep. Well, live stream is not always gonna be about electronics, like I mentioned earlier. It's gonna be about a bunch of other things as well. Yeah, so if you mess up on this part while soldering it in, you have to do everything all over again. So yeah, so I soldered the 3 connections there really well, but then the VCC and the ground pin got short and I had to desolder everything and go back at it again.
Beautiful. It's really beautiful when they snap together so easily. The actuator actually disassemble and assemble pretty easily. So with that, what we need to do from this part, instead of the other component, okay, I might have made a slight mistake. Instead of this part here, we need to.
So I have attached the ground and voltage connections again, and once again let's make sure they are not short. Yep, they are not short this time around, which is a big relief.
Okay, like this, and then we will insert this part.
And this one is ground and it's not short with anything over here. Yeah, I think we really need to calibrate everything to make sure there is no short connection or anything weird going on, because it's really difficult to gauge from only the soldering if everything is good or not.
Here we will have the motor. The motor over here. Yep. And on
The
this side we
SCL
will
wire
have
is
the output port.
I need to make sure this connection is small, otherwise if this one gets messed up I'm gonna have to remove these 3 wires that I've attached and redo everything. So I'm gonna make sure this is really small connection and it does not interfere with the other connections we have going on. Okay, looks good. I'm gonna solder it a bit more so it stays in its place. I am gonna remove this using this. I'm gonna clip it a bit. Yep, so now everything looks good. Let's check. Okay, this one turned out good this time around. And now I'm gonna just attach the CAN bus signals. Let me bring it closer to the camera and show the solder result. As you can see, these connections are really close together and it's really easy to get them short with each other. So yeah, you need to be extra careful when soldering this. Now I'm gonna prepare the CAN wires for this, and we're gonna move on to the next one after this. Yeah, if you guys are working on a humanoid robot, or if you guys are working on some other electronics or embedded project, I would love to listen what kind of projects you guys are working on. If you guys need help with anything, you guys can reach out to us and you guys can ask questions. I just saw this. There is this weird purple mark on this one. I don't know where it came from. Might be a manufacturing issue. But there is a purple marker writing here on this board. It's so weird to see. Okay, let's add the ground one for the CAN. This is a simple and straightforward job. But it needs to be really small. The edge of this wire needs to be really tiny. And then it's gonna sit nicely in its spot. It's not gonna wiggle around that way. Now let's attach the green one. We'll need to figure out after this live stream today how to proceed with the assembly of the body, because these assemblies are time consuming, as well as the wrong size of the hex insert we have really doesn't help with that. So it's not the wrong size hex insert. Okay, yeah, it's not very easy. Makes sense. Because there's a gap, a huge gap between the motor, and it's because you have to insert these parts just the right way. Yep. So I think a way to fix that would be, we can measure the. By the way, these are still connected. You can see that it's rotating, but there's a play here. Yes, and it's not supposed to be there. So yeah, let's just complete all of these connections, because with these connections, they're ready to be calibrated. They are ready to be calibrated. Yes. By the way, you're not making the connections for this right now. We'll just do it in the end. Yes. Really fast. That's why I'm leaving them. At the end, we're gonna speed run through those. So the thing about the hex screws is, if we want to, or if we think we have the time after this, once we end the live stream, we're gonna check, and we can order new ones from Amazon, or we can buy some from
Conan or some place like that, the ones that can fit perfectly in the space there. Because what we've realized while building this robot is the internal diameter of the hex screws is of no significance. It does not matter what diameter, internal diameter the hex screws have, hex stands have. So only the external size of the hex stand matters, and by that we have a lot of freedom to just go to the hardware store and look for the right sized hex stand. I'm gonna try applying a little bit of solder flux on the tip of this soldering iron, and let's see if it improves the tip of the solder iron. That was not a good idea. So apply it directly. Drop a little bit over here. It just if you apply solder flux, it jumps around a lot on the board, so you have to be extra careful that there are no other SMD components around the paste, because it's very easy to get them short in a scenario like this. So I'm gonna fix the black wire now. I'm gonna orient it the right way, and let's try putting it in its place. You need a really stable hand, because you might end up having short connections if it jumps around even a little bit. So chat, how is everyone? Are you guys working on any software or hardware, any technical projects at the moment? Any interesting just side or hobby projects? We would love to know. So we're usually working on hardware and software related projects pretty much all the time, and this is just one of them which we are currently sprinting on. So we would love to know what you guys are working on, and if there are any hobby projects or fun software projects that you have going on as well. On the other news, OpenAI Sora 2 has really good video generation, but they are using a lot of copyrighted material, of course, to no one's surprise. And AI companies have also been recently passing a lot of bills and laws in Congress trying to make it legal to scrape data from the internet to train their models on. And people have been making really funny, but ethically it's not like legal to just rip off characters, but really some really hilarious videos with different TV shows like Rick and Morty, SpongeBob, other IP protected shows like that, and using just a prompt from a model, like the model is really good at making replicating voice of the characters, replicating the art style and the motion of the character, the general personality as well. But of course it's all trained on copyrighted material, and it's not a good idea to. Yeah, so if anyone is a fan of any movie or any cartoon specific piece of entertainment, they can very easily replicate their own ideas into those cartoons, so they can make their own anime versions of that. And this is gonna get easier and easier in the coming years as AI evolves, as there's more progress, better models are available. So it would become pretty easy to create shows based off on other people's ideas by just with simple prompts. And obviously there's going to be startups and other softwares dedicated to the whole entertainment industry as well, so which will make it easier for people to animate things or create episodes or things like that, add music, add voice acting, all of that. So as years go along, and as AI becomes better and better, it's pretty interesting to see how this space evolves. Obviously, the copyright lawsuits, or those people who are concerned about this, they are gonna be playing their part as well. They're gonna try to suppress this, but there's a lot of companies in China, US, all around the world who are working on making their AIs better and better. So we'll see how these spaces evolve in the next few years.
Okay, yeah, so with each motor controller it's getting better and better. So the more soldering you do, the easier it kind of gets. I'm almost done with this one, and after that we have 4 more to go. It's already 2 in the morning over here.
How many do you have left?
4 more to go after this. There you go. And then I think we can make the connections for the
Power cables. Yeah, power cables.
Yeah, we haven't. Yeah. We
Motor. Sorry. The motor.
Yeah, but we also need to attach power cables as well. But those connections are really easy to make. We're just gonna breeze through them, real quick. Ground connections over here. I think I can move it a little bit here now. It's merging together. Let's remove this solder. So yeah, I need to be closer to the board in order to solder it perfectly. I moved my head away from the board and we ended up shorting the 2 connections. So I'm gonna move it back over here and let's try once more. Let's attach the last wire over here. And we're done with another motor controller. And yeah, this live stream is kind of going really slow and honestly kind of boring because it's just a lot of repetitive stuff soldering these connections, and they are pretty difficult To do so, you have to really dial in, otherwise you end up having short connections. It's a really precise job. You have to be really careful while doing this. I'm gonna move on to the next one. I'm gonna apply a little bit of solder flux over here. It would be really difficult to do this without any solder flux laying around. So if you don't have it, I would recommend you grab it. Solder flux makes it really easy to get your connections the right way first time without a lot of hassle or jumping around with your solder iron. So otherwise, if you don't have it and you're trying to only do it by using the tip of your solder iron, and you might end up risking a short circuit, and you will have to do the whole soldering process again. Yeah, the VCC and ground ones are the most difficult in this. So after doing that, I have to check for any short circuit and their connection with the PCB. Connection seems good, so I'm gonna move on to the signal wires now. We have the music on, so yep. And ideally with these live streams, they can keep going for a while. Yeah, but the thing is, where I am really focused on. No worries. I'm gonna have to redo this connection now.
our website is down, so there's some conflict between hostinger and the separate cloud platform we had of our own. So there's some conflict between them. So if anyone tries to access it, because there's a link on our YouTube channel, they won't be able to at the moment. I'll need to solve that. I'll do it maybe tomorrow or the day after, and then it should be good. Right now, we're not even sure if the emails are landing correctly. Have you tried logging into your email?
No. You should go to the website and check if the emails are active.
I saw a post earlier which was showing melting glaciers because of global warming in front of our eyes. And also when we went to the Osaka Expo, there was this country that had its entire design built around glaciers and melting of glaciers due to global warming.
I think when for the time being we are serious, we can increase the sound of the music.
Of the music?
Yeah.
No, I think it's good. I think too loud of a music is, and it's just not the right vibe for live stream. The lo-fi music sound needs to be a little bit less.
Connections for this one are done as well. Kind of tired sitting in the same position. Let's attach the CAN wires here and move on with the next one.
By the way, some random BYD dealers from Kingdom of Saudi Arabia keep sending me promotional messages for some reason. So like they somehow got my email and they're just sending me promotional messages.
Dude, wouldn't want your car, dude.
As well as from
Chill, man.
KSA, Kingdom of Saudi Arabia.
Yeah. What do you want us to do? Like fly all the way to KSA?
These big companies are still leveraging cold email at such a huge scale. They're probably hitting millions of numbers at a time.
Yes.
Millions of emails, just randomly spamming emails.
Yeah, and it probably ends up working for them. That's why like they're doing it
Yep.
all the time.
Yeah, these companies are smart. They're spending a lot of money gathering these emails and sending these cold emails is probably working. Most likely.
Or yeah, their scale is just like so big.
Yep.
The outbound list is so big.
Yeah, it's because they have a defined product. So they have a product, they have sort of an ideal customer profile, target audience set up. So at this, once you have those basic things defined, then you can really ramp up your campaigns. Then it's just about the volume and the scale. They're by no means a small startup or a small company.
Yeah, definitely not anymore. The government of China is also like in a weird way involved with everything. Because most startups, most successful or really high-tech startups in China are state funded or state sponsored, and they do work in really close proximity with their governments, close collaboration. Let's add, this is the third last piece, and yeah, the main issue at this point, I can imagine with the 24 gauge wires, all of this would have been way more easy. If the wires were smaller, I would probably be breathing through these connections as well at this point. The first few are for sure a bit difficult, but after that, the main issue I'm having is these wires are too thick and they are like right on top of each other because of their size. But if you'll be using the 24 gauge wire, it should be really easy for you after the second or the third controller. The rest of them should be really easy to solder. Okay, I'm gonna bring it a bit close. I don't want it to get short with the ground wire, so I'm gonna attach a little more solder wire over here and make a nice bubble, and then I'm gonna apply a little bit of solder on this wire as well. Yes, so this makes it a bit easy to join these two. Okay, so I don't think there's anything short at this point, so we can move on with the signal connections now. And they are really close together, so you need to make sure they do not latch into each other and they don't form a short circuit. Yeah, now that I remember, if I remember correctly, I got a copyright claim for the latching music. Latching on. So maybe it is not copyright free after all.
It's such a good song. Of course, most likely someone has the rights for it. It's not publicly available, copyright free.
Yep. Also, the thing with copyright free music videos on YouTube is they do tend to stay copyright for a while, and after a while, suddenly they have copyright license attached to them, and sometimes they do send a strike or a claim your way after a few years. So it's not a good idea to use those quote-unquote copyright-free music videos straight up from YouTube, because you don't know what the situation of the license is gonna be a few years from now. You should be using services like, I'm not sponsored by them of course, though I wish I was, but you should be using services like Epidemic Sound, or what's the other one, In Water Elements. I think this one is also done. We only have 2 more to go after this.
I think we can call it a day after that.
Someone needs to measure a time on this. I'm speed running through them now. So the first few are a bit difficult, but after that, the rest of them are easy once you get a hang of it. And of course, if you're using the correct wires, it should be way more easier for you guys. Because these can wires, they are like so easy and simple to attach in their positions, because they are so thin. Their solder points are also really thin, but because of their thin size, it's so easy to attach them where they belong.
Alright, this is also done. One task aside. What else do we have? I think we had many other tasks. Yep, that as well.
Okay, I'm gonna place this one on the side now. This is also done, somewhat done now, and now we're gonna move on with the second last piece. Once again, this solder flux has really helped with the process. It would have been much more difficult without it. It's a real lifesaver. I'm gonna bring in this one. Shout out to the guy who invented solder flux. He made soldering easier for all of us. What a genius guy. Yes, so here's a trick I have learned. Because these joints are really small, if you apply a little bit of solder on top of these wires before putting them in their rightful place, they latch on to their spot really easily. So that's what I've been doing lately with these controllers, and that's why I've been able to join them relatively quickly and relatively
relatively in a more precise manner. Perfect. So yeah, I am having much more success with it recently because of this trick. I'm gonna apply it over here as well, some solder, and this will help the wire, the copper part of the wire in latching onto the solder at the bottom. I am gonna move it a bit closer. Once again, I think this connection is perfect. There seems to be a little bit shorting going on. I'm gonna have to make sure that's not the case. Otherwise, I'm gonna have to remove the red wire. Nope, all good. All good. Let's see for the short connection again. We don't want the voltage wires to be short with each other. Okay, perfect. Now to solder the two remaining signal wires. Little bit solder on this blue wire over here. I'm gonna move it closer. Perfect. The last one for this controller, the last one for the second last controller. Chat, are you guys enjoying the stream so far? And if you have any recommendations for us to add or edit anything that would make it a bit more fun or entertaining, feel free to let us know. This is just our 4th live stream on this channel, and we have already made some adjustments. So we've added the music, we've added this little character which is moving at the bottom of the screen. So if any one of you leaves a comment, your character will appear at the bottom of screen as well, along with the comment. So that's also a fun feature we added. We also have music going on, which we're doing for the first time today, and yeah, we'll keep improving it one by one step at a time. Yeah, I think we will have to modify the name of this live stream. We added assembling the robot in the title, which we are not oh yeah.
Yeah, we're not putting together the upper part of the body of the robot.
Yeah,
because of
someone
obligations.
Yeah, someone in the future who
yeah, no,
comes here watching the video will be thrown totally off the
No, like of course you want to know we can change the title of the stream with the live stream
A bit like
midway.
as well. No?
So if you go to you can edit it from there. Just click on the edit button over there and just remove the. So the name of this live stream should now be assembling soldering motor controllers.
We'll just do it right after the live stream. And
Yeah, no, I just want to see if we are able to do it midway. We probably are. Yeah, just remove the upper body part and
just motor
only
control.
keep motor controllers.
Alright, I'll just save this.
Save it. So the name is gonna change, right? Yeah, and we can also like change the thumbnail that appears and everything while the live stream is going. It's such a cool feature
Interesting.
from these platforms.
Interesting.
So there's a typhoon coming here in. It's gonna hit Tokyo sometime around tomorrow, and it's gonna stay here for a while. It's gonna move through this whole region of the Pacific, and it's gonna pass above Tokyo as well. And for a while, it's gonna be raining cats and dogs. The weather's gonna be really cold. And after that, generally the weather is gonna stay cold, I think, for the rest of the year. This time, because of the whole global warming thing, winter in Tokyo is a bit delayed, but October is the month everyone's expecting for it to get really cold again. We just have one more to go. Let me double check the shorts on this, if there are any short connections or not. These ones are good. These ones are also good. These ones are also good. Okay, so time to move on to the last one for the day, which is this boy over here. And what? This is a weird one. Why does this one not have a? This one doesn't have a VCC. Let's put it to the side, and I'm gonna grab one which has all these proper.
Yeah, we'll just screw this afterwards.
Yeah, we're gonna put this on. This one is. Let me try to find a more like stable one. Yeah, I think this one is good. I'm gonna have to prepare these wires now. Yeah, you don't need to expose a lot of copper, otherwise these wires are gonna dangle around and they're gonna get short with each other. So you really need to keep this section. Let me double check with the motor connector over here. Yep, and it's gonna be difficult for them to not get short with each other if you expose a lot of these, a huge chunk of these wires. There's a nail cutter, and let's put this one over here.
unbelievable progress with robotics. So this is a Chinese company. It's Unitary Robotics. If you've seen their robot and their demo, it's just unbelievable.
Yeah,
And
it looks AI generated.
Check
like,
this, check
the
this.
way it's
No, it is an original video. It's on their official account. Check this.
yeah.
With a chair.
Yeah, the way it gets back up, it's so insane.
Yeah, unbelievable. And the thing is, in China, there's not even just one company that's making these robots. As we've seen with that YouTuber who makes really good humanoid robots. There are many companies, each one of them making a robot within months or like 1 or 2 years that's better than any robot in the entire US.
Yeah.
Their pace is unbelievable. There are really amazing companies in China.
Yeah, it's a bit difficult. Yeah, this way it will be a bit easier. So I'm getting a little bit of solder on all of these wires. So later on, when I'm about to attach them over here, it's gonna be a bit easier to do so. Okay, let's grab the first wire, which is the black one, and let's put it over here. Okay, this one I think has been the most perfect solder joint yet. Let's put in the red one. We don't want it getting short with the black one, which is the round one. Perfect. Yeah. Now this is the last one I'm making, but all solder joints are turning out absolutely perfect. Let's move on with the second last signal wire. Good. Last one. Tomorrow is like Monday, right?
Yep. Tomorrow is Monday.
A new week begins tomorrow.
We can call it a day after this one, after this actuator is finished. And then based off on the CAN USB and we're not sure if we can move forward with the assembly at the moment because we'll need to disassemble all of the actuators and we don't want to get in a position where we have the assembly built but they're not calibrated and we have no clue where each actuator is on the entire body. It will just waste not just one, many of our days afterwards reassembling, disassembling, reassembling. So we want to make sure first of all we have USB CAN and the right firmware is flashed, the motors are calibrated, they are separated according to each joint, and then we can assembly comes after that.
Yeah. We also want to make sure once we have the hot glue in and the joints made, we don't want to just keep separating them again and again.
Yeah, let's rethink about the timeline of this after this.
I think we can get a good video for a tutorial from here. I don't know how close I was while soldering it, but I think it should be good enough. How is it looking in the video? Is it making any sense? I guess yeah. If we zoom it in, a person should be able to see. Our lab is a mess right now.
So just like the lab we visited in Pakistan, we have BLDC motors just laying around besides your chair, below your chair.
Yeah.
Open packs of BLDC motor just laying around with no clue where the parts are.
Yeah.
It's really messed up. If we were to try and find all of the motor parts, we would have to put in some effort this time.
Yes. It's kind of messed up at the moment. These 4 joints are absolutely perfect. These 4 are just really beautiful. So yeah, these are the last 4 joints I have made, and you can see they are really close to each other, but they are not short at all. And then these are the CAN wires I have attached over here. I guess that's it for today. Let's call it a day. And thank you so much for watching the video, guys, and a big shout out to Reg for commenting and having a chat with us in the chat section. We're gonna rethink about the timeline on building this robot. After this, the next live stream might be about this robot. It might be about something else, maybe 2D animation or something like that. But there definitely is gonna be a next live stream, and we're gonna improve something each time. And yeah, that's it. Yep, that's it.
See you guys in the next one.
Thank you so much for joining, everyone. Cheers.